start off today's class. Okay. So yesterday we rounded up on programming in C Sharp, introduction to programming in C Sharp, and we're able to cover up arrays, conditional statements, more on conditional statements, and then loops, and then we looked through switch statements, and we created a simple database system using arrays. Okay, checking through registered players and their registered pins, and then we also saw how to structure a class. All right, I explained how to structure a class. So we can, and then the assignment. I've sent the assignment over, so I guess it should be on the group by now. You guys can go through the assignments and everything you need. There is a link that has been added to that assignment. Okay, the link would lead you here. All right, you would have the template for you to create the calculator, and then a recording of what you need to put everything together, then a brief like a summary of the entire introduction to C Sharp course, and then this program.c sharp file, which is what we used to code all of this in case you need to go through. So you would have access to all of this, and then the templates to create your calculator. So okay, let's jump right into Unity. Okay, so we have, so this is Unity Hub. I would hope that we all still know how to use Unity Hub, and today we're going to be starting off with introduction to Unity. Okay, scripting in Unity. All right, so we're going to start scripting with Unity since we already have an understanding of how to program using C Sharp. We're going to start doing the same with Unity. So we're going to be using Unity to create scripts that would run our game, okay, or our game project in Unity. So yeah. I'm waiting for this to load up. Okay, there we go. Okay, so this is where we stopped in the Unity project, but we're not going to be working with this today, even though it is a really nice looking environment scene. Today we're going to be working back and forth with Visual Studio Code, VS Code, and the Unity scene. So go to where you have scenes, and then create a new scene. Okay, create a new scene, and let's call it something like intro to scripting. Okay, since that's what we're doing, we are scripting. We're learning how to script in Unity, how to create code in Unity, and then just double click to open it up, and then you have the default Unity scene. So yeah, you can create when you go to your projects window, you can create a new folder, and then you can call that folder scripts, or I like to create a scripts folder where all my scripts would be in. So depending on how large your project is, you can have like subfolders where you have maybe folders that would only be tailored towards the player movement and the player movement, the player manager, everything related to the player. You can just have a subfolder called player within your scripts folder. And then anything that has to do with managers, maybe your game manager, your audio manager, your menu manager, you can have a managers folder. Depending on how large your project is, you can have like all these subfolders. But in our case, we're not going to be doing too many crazy things. So let's just have a simple script here. So to create a script in Unity, okay, because Unity has a VS Code plugin that allows Unity and VS Code to, communicate and interface properly. You scripts in the VS Code, it compiles, and then you can run those scripts, run those code in Unity. So you have to right click within the folder, okay, create, and then C# script. Okay, C# script, you'd be able to create a new C# script. I can call this, let me say, basic script. Okay, so basic script. I want to use this basic script to sort of explain the basics of scripting in Unity. So yeah, that's why I'm calling that basic script. Okay, so I'm just going to go through that everything that goes on when you are coding, for a Unity project. Okay, so let me increase this so that we can see. Yeah, I think that is much better. Okay, so where we last stopped, unable to sync settings. Okay, where we last stopped in introduction to C sharp, we looked at classes. Okay, we looked at classes and how classes are structured and how they are declared. So a for a default Unity class, there are a bunch of things that are needed. Okay, so there's something we call namespaces. Okay, these namespaces are they're like a way to, let me say, fit in a particular let me say a particular behavior, okay, a particular set of behaviors within a class. Okay, so these is sort of like, let me say, they sort of encapsulate a bunch of classes, functions, methods that you'll be using. Okay, so in this case, we're going to be using we're going to be using a couple of .NET default namespaces, okay, which most of them would be these, okay, Unity using systems.collections. So when you declare this like using, okay, this means you want to import this particular namespace. Okay, you want to import this particular plugin, this particular asset. Well, when scripting, you use like this is the Unity engine's namespace. Okay, so this is the system dot collection namespace. So they are all namespaces. Okay, so in this case, this using Unity engine, this namespace contains everything within the Unity engine. You get, so a namespace is like a container for a bunch of assets, plugins, scripting APIs, and whatnot. Okay, so it's basically what we're doing when declaring all this is saying, okay, we need a bunch of APIs, we need a bunch of keywords, we need a bunch of assets, a bunch of functions, methods that we are going to use to create this script. So this system is .NET's way of packaging all the necessary properties and components you would need to work with a project. The same with this. Okay, so .NET uses a general namespace called system. Okay, this is C#.NET. Okay, and then within system you have other namespaces in there. You have namespaces that contain mathematical formulas, mathematical functions, which are contained within the namespace.collections, namespace.collection.generic. So these sort of namespaces have things like mathematical functions, arrays, um, random range, time, and a bunch of other things. As we move on, you'll be able to see all of those things in action. And then another particular namespace that you would be using while trying to save information, maybe get info from a path or save data to a path, you'd be using a namespace called system.io. Okay, this io, I can't remember the full meaning now. But it saves so it allows you to save data and retrieve data from the system. All right. So these are the basic namespaces you'd be using. But for now, um, these anytime you create a new script in Unity imports these namespaces for you because these are the most used namespaces for you, and the most active is going to be the Unity engine namespace and then the system.collections. This is just an addition in case there are some generic functionalities and keywords you need. So yeah, so let's look at you know the one of the basic things you'd be working with in Unity, one of the most used things in Unity. So remember I said you'd have to have a all of these within a class. So Unity creates a public class for us. Okay, the reason why Unity is using a public class is these classes have to be accessed generally in the project. Okay, so you need to have them accessible like basically everywhere in the project. Okay, anywhere you have to get them anywhere. So that's why it's using public and not static or private. Okay, they're not static because it's not just going to be used in one particular place. Okay, you can access them from anywhere within the project. Okay, so now that we're using a public class, we can use different types of modifiers or identifiers within the scripts or within the class. So let's start with a public. Okay, so you declare your variable starting with public, then the variable name. Let's use, before I go, so we can just have something like public integer and then call that player score. Okay, and this time, since we're using a public class, we don't have to necessarily declare what that is, but just to be safe, you can declare a default value for that. And then we can also do, a public string. Okay, and then give the string a name. Okay, player name. See, it doesn't give us any issues like when we're using static variables. Okay, so but just to be safe, always give a default value of let's say player. Okay, just in case. But these are general C sharp variables. Okay, these are general C sharp properties, but we want to work with Unity um, components. Okay, Unity variables. So the one you're going to be working with the most, or the two you're going to be working with the most, would be these: a public game object. Okay, so public game object, and we can call it game object. Let's do that for now. Okay, since I'm still explaining stuff. Okay, okay. So the script is going to be on a game object. So calling it the game object again is, so let's just say G object. Okay, okay. So yeah, that makes more sense. So yeah. So that is the reason why Unity will allow us to use game objects is because the script itself is most of the scripts are usually placed on a game object. So if you want to access the game object the script is on, all you just have to do is do game object. So that gives you access to the script itself. So the game object which the script is on. So it would be weird if you have like a game object, you grab. So that's the issue we had over there. All right, so this game object is basically an entity in Unity scene. Okay, so if I close this and go back to Unity, so as I said, is to compile the code and then you can go back to work on this. So if you come back to Unity and we want to create these, you can see this. So every object, every entity in the scene is referred to as a game object. Everything you bring into your scene, okay, if it's a cube, a sphere, a quad, a UI element, every single thing that would be in your scene in Unity is referred to as a game object. Okay, and if you want to reference that particular, if you want to reference any object in your scene, the namespace, the variable name or component name is game object. Okay, so you have to declare it as game object. It's called a game object. Okay, another very important component that you would be using a whole lot would be the transform. Okay, so you can just say okay, we can't use transform too because the transform is the transform property. So let's just see let me see object transform. Okay, so yeah, so this transform is the property, okay, that represents the position, rotation and scale of a game object and allows you to manipulate and access these properties. Okay, so when you call a transform, okay, when you declare a transform, yeah, especially if the transform is public, it gives you access to the transform property of that game object, and the transform property contains the position, the rotation and scale of the game object. All right, so if you want to move a game object forward, backward, you want to rotate the game object, make the game object larger or smaller, you would need to have access to the game object's transform property. Okay, as I said in the very first class, okay, the transform can be seen, the transform property can be seen in the inspector. Okay, I'm waiting for this to just quickly compile now. So let's create a new game object, a new cube. Okay, if you go to the cube, see this is the cube. So this cube is a game object, and then this is the transform property of the game object. All right, so this is the transform property of this game object. Okay, so if you're already in the game, you can't manipulate the transform anymore. Okay, you know the way we can move this left, right, up, down, and so on and so forth, forward, backward, and so on and so forth. We can do, okay, notice this, when we move this, pay attention to the transform property, it changes, the values changes. Okay, so if I try to rotate this, you see the rotation on the y-axis changes. Okay, so in the game scene, you won't be, when the game is running, you won't be able to change all of these on runtime. Okay, so you would have to script them if you need them to change within gameplay. Like you are moving a character forward, you want to move the character left, right, you would need the characters or the player's transform property to be able to do that. Okay, so that is what you would be using. Those are what you'll be using a whole lot in Unity. Okay, all right, so the mono behavior class, okay, we can see that almost every script in Unity inherits from the mono behavior class. Okay, this class is the base class, okay, for scripting. in Unity. Okay, it allows you to define behaviors, game objects, inherit from the game objects. It allows you to manipulate and modify vectors, integers, floats, basically everything that runs within your game. Okay, if you want to script a behavior, call a method, an event, an algorithm, store data, access data, you would need to inherit from mono behavior. So it's the base class in which every Unity script derives from. Okay, so these are one of the most used components you'll be using. Another very good component you're going to be using is the rigid body component. So you can just say rigid body. Okay. So let's just do RB for rigid body. Okay. So the rigid body component. All right. So this component is okay. This component controls the object's position. Okay. It controls the object's position through physics simulations. So if we go back to Unity, I'm going to explain. So all of these components that I'm talking to us about right now are the basic components that are going to be in Unity. Okay, so let's say, so for this cube, we can add that rigid body. So rigid body. Okay, so the rigid body components is the component that allows us to manipulate the physics of a game object. Okay, you would have heard that the game engines run with a physics simulator, and then it does mathematical calculations and all of that. So the physics part of a game object is controlled by a rigid body. For those of us who would remember in physics, you would have heard of a rigid body. So this is Unity trying to replicate that in the engine. All right. So the rigid body has mass, drag, gravity, kinematics, collision, constraints, and all of those components within itself. Okay, within its property. Okay. So if we want to increase the mass of the rigid body of the game object, we can just go into the rigid body, something like this. Okay, so something like this. So we can just do something like so RB, since we declared that rigid body, so we can say RB dot mass. You see, so you can just say RB dot mass. That's the mass of that rigid body within the game object. We can make this 100. Okay, so if we want to change the mass of a rigid body, declare the rigid body, give it a name, and then you can change the values of its components. Okay, so that's the mass. If you want to change the velocity of the rigid body, let's say the rigid body is moving forward. If you remember in physics, you can manipulate speed, velocity, and all. You can use the rigid body velocity. So if you want to change the velocity, you can just say the new velocity that this game object, let's say your player is running with a particular velocity, let's say velocity of 5, and then for some reason you want to change that moving velocity, you can just change the velocity here to 10, and then you can always somewhere else return the velocity back to 5. Okay, so the velocity, okay, no, the velocity is a vector 3. Yeah, forgot. The velocity is a vector 3, so you have to do this new vector 3 because the velocity needs a direction. Okay, so the velocity needs a direction, so it is a vector 3 component. Okay, so which would lead me to explaining what a vector 3 is. All right, so I will do that in a minute. Okay, so this is, let's say if you want to move, so let's just say x, y, z. We want to move it forward, so let's say 10 f. Okay, and then take it back to 5. So something like this. Okay, so this is you moving the velocity forward Okay, but now let me just quickly explain. So that is how you can so that is how you can access the rigid body component, and it works the same way for any other component within Unity. Okay, so even if you had, okay, so let's use another component that people would most likely use, that you would most likely use. Um, this is not something that you would use often, but for the purpose of this, let's just, why does it keep restricting me from doing those things? Okay, so let's just do that. Okay, so this box collider allows you to, actually interact with other game objects. Okay, actually allows you to interact with other game objects. Let me explain. So I have this cube at the center of my scene right now. Yeah, and this cube has a rigid body. This cube has a rigid body component within it. Okay, so if I wanted um if I wanted this cube to fall, yeah, I just activate gravity. Gravity is a force that pulls all objects towards the center of the earth. Okay, so now we are falling downwards because gravity acts downwards, like, pushing downwards. So the rigid body has the use gravity boolean set to true. So if I play this now, you would notice that the cube would just start falling. Okay, the cube would just start falling. Okay, until it falls out of our view. All right, but now if we create a plane, okay, if we create a plane, okay, let's just add material to the plane so that we can differentiate between these two. So let's reset this and then go there. All right, so this is the plane. Let's put the plane somewhere down here. Let's remove this. Okay, let's put the plane somewhere down here so that I can explain something, and then zoom out a bit. Hopefully you can still see what's going on. Okay, well, let's do this, which is better. All right, let's do that. Okay, and then if I play, you would notice something. Even if the plane is there, the cube will still go right past it. Okay, the reason why that is happening is because the plane does not have a box collider. It does not have a collider. Okay, so a collider is a shape or like a collision property for game objects that enables them to collide with each other, to interact with each other. Okay, so we can either add a box collider. So there are different kinds. If I search for collider, you see we have a bunch of colliders. So there's a box collider, 2D. If you're working on a 2D project, you can use a 2D box collider, a capsule collider, 2D, a circle collider 2D, composite collider, and all of that. So a sphere collider and so on and so forth. But for this, and then we also have a mesh collider. Okay, so if you have a mesh renderer, okay, a mesh renderer on your property, on your game object, you can always use a mesh renderer. So let's give it a mesh renderer and make it convex, okay, so that we can see. So this is the collider. This is the collider we have on our game object, on our playing game object. But let's just remove that. And if we want to use a box collider, we can just use a box collider. So the box collider will automatically take the shape around the game object. Okay, it will create like a box around that game object. Now let's save and try to play again. Okay, if I zoom out and then play, You notice something this time. Now it collides and stays on that plane. Okay, it stays on that plane, meaning it's interacting, it collides with the plane. Okay, this cube has a box collider, the plane has a box collider. So if both game objects have colliders on them, it allows them to collide with each other. They'll be able to interact with each other like that. Okay, so a box collider, a collider, or a collider component allows objects or game objects within a scene to interact with each other. So you can also manipulate a collider's property, okay, by doing collider dots. So you can change, you can either, if you don't want a collider to be enabled, okay, let's say you want your player to have um a sort of ability to walk through walls. Okay, so you can just maybe change, you can just disable a collider within frames, and you can do that using collider.enabled false. Okay, if you do that, the collider stops working. Okay, it's no longer enabled, but that is on one side. Okay, so these are basic properties that you'd be using. There's also an audio source. Okay, audio source properties. So I can just say audio. Okay. Okay. So I can say audio source. Okay, so this audio source is, it represents audio sources within within the project. Okay, so you can have an audio source, you can have a renderer. Okay, you can have, so there are a bunch of components that you can use within Unity, but when it comes down to it, these are some of the most used properties, basic properties you would use in Unity. You would only be using the colliders when you want to maybe switch on or off the collider, maybe get a colliders property, but it's not as used as these ones. You would also use the audio source, and getting an audio clip. Okay, so let's say clip. So the audio clip is a container of audio, so it has audio. So maybe you want sound effects, you want background music or whatever. So all of those, your MP4, your WAV, your OBB, they are all audio components which you can drag and drop into the game. Okay, it's referred to as a clip in Unity, right? So that is what you would use to, that's what you assign to an audio source to make it play audio. So an audio, so if you wanted this audio source to play this clip, you would do something like audio source dot play, and then you can just put in that clip there. Okay, so okay, you can put in the clip there. Oh, sorry, you can just assign the clip you want to play. Okay, so you can assign the clip you want to play equals clip, and then, so that's the property. Okay, so the audio source has a property called clip, so you can just change the clip. Let's just change this to my clip so that we differentiate between them properly, since it already has a component called clip. So my clip, and then you can just do audio source dot play. So you can give it a clip and then tell it to play that clip. Okay, so you can just have your audio source there. So the way you put in the way you work with your player, maybe your music player, you select a song, okay, and then press play, and then the song starts playing. So basically this is what you're doing here. You're telling it, okay, this is the clip I want to play, this is my clip, and then play. Okay, and then if you want to stop, you can also do audio source dot stop, and then it will stop playing the song or the clip. All right, so that's how that works. So we have a bunch of components that for now we might not really go into because we're still starting off with them. And then let's go into a very fun part of game development. All right, so that is with vectors. Okay, so let's quickly look at vectors. All right, since we've looked at basic components, let's look at vectors. Okay, but before we look at vectors, let me explain. I'm sure you would have noticed these two functions, this empty functions, all right, that don't return anything. So these are the default methods that run with every Unity script. Okay, so this start method is by default the first method that will be called immediately your game starts. Okay, so when your game starts, the first frame, okay, the first frame of the game, if you want to do anything, like if you want to put in something, okay, that at the start of the game, let's do this for this particular game object, you would put that in the start method. Okay, so if you look at this comment that Unity generates for us when we create a script, it says start is called before, it's even called before the first frame. Okay, so it's called before the first frame. So if you want something to happen right at the start or before the first frame, okay, you would use your start method. Okay, so a very good example for the kind of things you would do is just because you have these components doesn't mean the components are going to do anything. You have to get them. Okay, you have to assign them to something. Right now, they're not assigned to anything. Okay, they don't equal anything. Right now, they are null. Nothing is in them. Okay, so these are all null. All right, all of these are null. Right now, as it is, nothing is working within them. Okay, they have just been declared. They don't have any value right now. Okay, so the best way to do that, okay, if we do something like new rigid body and then do that, it's still nothing because you have no necessary property for these, and everything you need is in the game engine itself, so you have to locate them within the game engine, but you can do that too within this space. How? Okay, so now we have, let's use the rigid body. Okay, let's use the rigid body and the transform. Okay, so we know the rigid body is called RB. Okay, so RB on starts, okay, before the game loads up anything or before it starts running anything, we need to get the rigid body of this particular game object. And in order to do that, we would use the get component. Okay, so and like I said, the rigid body is a component that you add to a game object for you to simulate the physics of that game object, like the gravity, the velocity, and so on and so forth, the mass, and all of that. Okay, so you can use the get components, okay, the get component method, okay, and then find the rigid body components of that game object. Okay, so this tells Unity that on start, okay, assign the game object's rigid body to this rigid body. Okay, we can do the same thing for the transform. Okay, sorry, so transform is object transform, and we can just say get component transform. This would make sense normally, okay, but Unity already covers that for us. Okay, if you want to access the game object where the script lives, if you want to cover that game object's transform, okay, or any game object's transform, all you need to do is this. You just say transform, okay, that's it. Okay, that's it. But if you want transform dot position, so if you wanted the position of a transform, you can just do transform the position. If you want the rotation, you can just do transform the rotation. Okay, so that's how that works. But if you wanted to get the transform of a another game object, okay, a game object that you don't know from start, okay, you can assign this game object in the scene, or if you're doing it at runtime, you can just do something like this. Okay, you wouldn't use this, you can just assign, you can just do something like, okay, so object transform will equal, let's say you already have this game object assigned to something. Okay, so you can just say that game object gets its transform, and then this object transform becomes the transform of this game object. Okay, so that's how that works. I hope you understand that. All right, so if you have any questions so far, please put in your questions on the chat. Let's see. Oh wow, stock IP is good. Can we? I hope hope you can see it. Please respond as quick as possible so that I know and then continue. Okay. Hopefully we can all see my screen properly now. Okay. All right. It wasn't stuck on my end. Okay. I think probably you can, if you're still having a problem, Moses, you can go off and come back. Probably it's a network issue. Okay. I wasn't. So how much time? Okay. So yeah, that is that's how that works for Unity. Okay, so you can do that for let's say the audio clip. Okay, so if the audio source is a component in your game object, you can just do, okay, the only two so audio source. Okay, so that will automatically assign the audio source component to the audio source, and then anywhere within the script you can manipulate, change, and do whatever it is you want to the to the audio source. All right, so something else, okay, yeah, I was about to say something. The only two objects you don't have to do this for, okay, are the game object. Okay, you don't have to do get game objects because game objects are always there. All right, okay, so you can always say game object dot something, and then it automatically does that for you. Second other one is the transform. Sometimes even the game object, the collider. Okay, you have to get the collider. I think they changed it in 2018 or so. So yeah, before you could do game object the collider, but I think now you have to actually get the collider. So you'd also, so for the collider, you'd also do get components, so box collider. Okay, so yeah, for that you'd have to do that. So the only two you can just reuse are the game object and the transform, like so, and you won't have any problems accessing that for any game object. Okay, all right. So, and then you can, if the component is not on your if the component is not, if any of the components here is not on your script, or it's not on the game object which your script is assigned to, you can do this. Okay, so let's get rid of all of these. Okay, but be careful when you do this. You have to make sure that you have only one of this to do this. So there has to be only one within the scene, not within the entire project. Okay, within that particular scene for you to do this. Okay, let's say you want to get a rigid body of another game object. Okay, you can do find object of type. Okay, before we did get components. We're getting components because the component is a component on the game object. Okay, but now we need to find the object that has that component. So in this case, we'd use find object of type. So object of type rigid body. Okay, the object must have a component of type rigid body. Okay, so that's why you use find object of type rigid body. Okay, so if there was okay, we can't use this because sometimes a whole lot of game objects have rigid bodies on them, so this might give you an issue. Okay, but I'll show us very soon. By the time you start working on stuff, you'll be able to do that. Okay, so you can easily get components that way. Either you use the get component or the find object of type. Okay, if the object is not on your, and then you can also do if the game object is somewhere within, like your children. I told you, if a component, you can have a game object within a game object. That way they have a parent-child relationship. So you can do you can get a component within a child. So you just do get component in children, and you can also do get component in parents. So if the child wants to get a component that is in the parents, you can just call the get component in parent method. All right, so those are the easy ways you can access components or assign components to the given to the base components that you have. All right, so yeah, that is that. So let's go to the update method. Okay, so the update is called once per frame. Okay, so how we looked at loops. Yeah, how we looked at loops in C#. So the update method is like a never ending loop. Okay, so when you start your game, a loop starts. Okay, and that loop checks for every single thing running within your game. This is the update method. It will keep checking per frame. So a frame can be, you can have about 60 frames. Okay, you can have about 60 frames within a second, depending on how fast your game is running. So if you're running 30 frames per second, you would have 30 frames in 1 second. So this update method would run 30 times per second in the course of your game. Okay, so if you have a game session of maybe 100 minutes, okay, it means the update method has run 100 minutes times 60 seconds times 30 frames. Do you get that context? So that is what your update method does. It's a never-ending loop that runs every frame. Okay, it calls itself again and again and again per frame. All right, so that is the update method. Okay, let me make sure I get this. All right, so that is the update method. So now let's check out other methods that are very much usable within Unity before we jump into vectors. Okay, because by the time we get into vectors, we're going to be looking at a whole lot of crazy stuff. All right, so one very good example is the what happened there. Oh, jeez. All right. One very good example is the sorry, I'll check that out later. Okay. One very good example is the fixed updates. Okay. Yeah, this is the fixed updates method. Okay. So this fixed update method, all right, allows us to it works the same way as the updates method, but it gives priority to physics um physics components. Okay, it gives priority to physics components. So let's say you want to do a let's say you want to maybe draw a ray cast, or you want to use your rigid body, or you want to check for collision, anything that involves interaction, it's always advisable to use your physics updates over your normal update method. Okay, and then there is another one called the late update. Okay, so the late update is as it says, late update. So it happens after everything has happened. So it happens after your updates and fixed updates. So let's say you wanted to move a game object, okay, but you wanted that game object to be a little bit slower compared to what the other game objects do. Okay, you can put that functionality within the late update. A very good example is your camera. Okay, so let's say you are playing a third person game, or like let's say Call of Duty and all. You know, you're moving with your joystick or WASD, you're moving forward, you're running, you're sprinting, and then you're also moving your camera left or right. So what this does is it allows so you can put your input here. Okay, your input here. You can put your rigid body RB dot velocity here. So when you move your joystick in the updates, yeah, it moves your velocity forward. Let's say you moved this to move forward, it moves your velocity forward, and then you also put, so let's say input for movement, and then another input for camera rotation. Okay, so it will take both inputs and then it would run this first, and after it has completed running this, it would then run this. So this is where the camera movements will happen. So you're running forward and moving your camera left and right. It would allow your player to move forward based on the velocity that has been given before your camera actually moves. Okay, the reason why it's doing that is you don't notice that because everything is happening within a frame. Okay, it's happening every frame. But when the game engine is computing all of these events, all of these actions, it would actually take priority to the updates, the physics updates, before it gets to the late updates. I'm not saying you can't put everything in the updates. Okay, everything can actually run in the updates. Okay, but it only works better or works faster when you assign them to where they are supposed to be. Okay, you want to do anything physics related, put them in your fixed updates. You want to do something that normally runs after the other things, you put them in your late updates. Okay, so these are Unity's basic default for methods. Another very interesting method that Unity does for collision. Okay, Unity uses to, okay, when we come back we would continue with that. I think the meeting is done. Okay, all right, let's join in. Class ended already. Okay. I don't know what's going on. Okay, let's see. Why is this not sounding now? What's going on? Okay. Right, yes, okay, the mic is working properly, but the speaker is not working. Hello. Okay, let's try again. Not working. Okay. I think it's use microphone. Everything is allowed, so it's still not responding. Okay. Okay.